Let us continue ionic equilibrium subjective numericals. In this, first we will see H3PO4 numericals. We will see now. We will take this ionic equilibrium numerical. In this one, what they are asking, you see that they have given a 0.1 molar H3PO4 solution. 0.1 molar H3PO4 solution. For that, K1, K2, K3 is given. Now, what we have to find? We have to find concentrations of all species of significant concentrations. This we have to find it. Sorry. Now we will take H3PO4. Step by step we will go. Now for H3PO4 we are taking this H3PO4 ionizing to give H plus ion and H2PO4 minus ion. Now H3PO4 initial concentration is how much, in the sense 0.1 molar. H3PO4 initial concentration is 0.1 molar. H3PO4 dissociating x molar. At equilibrium 0.1 minus x will be present. Concentration of H plus will be x molar producing, H2PO4 minus x molar producing. Sorry. Now, for this equilibrium constant we can say as Ka1. Ka1 is the equilibrium constant. That is equal to, right side things we will write in the numerator, that is H plus, then H2PO4 minus by H3PO4. Like this we have written. Now we will substitute Ka1 in the sense, in the equilibrium, what should be there, means acid should be there, and corresponding its univalent conjugate should be there. Acid, this net charge is 0, its conjugate, univalent conjugate should be there. That is only Ka1. Ka2 in the sense, univalent acid, corresponding conjugate bivalent should be there. Ka3 in the sense, now let us see ionic equilibrium subjective numerical. Here, calculate the concentrations of all species of significant concentrations present in 0.1 molar H3PO4. 0.1 molar H3PO4, K1, K2, K3 is given. Now first we will take the H3PO4. What is given in the sense H3PO4? That H3PO4 we will take this H3PO4 dissociating to give H plus and H2PO4 minus. H3PO4 we have taken 0.1 molar. H3PO4 we have taken 0.1 molar here, that is given. H3PO4 0.1 molar given. Then H3PO4 dissociating x molar, remaining is 0.1 minus x. H plus produced x molar, H2PO4 minus produced x molar. Now we will go for equilibrium constant Ka1, that is equal to, right side things we will write in the numerator, left side thing we will write in the denominator. Now we will substitute Ka1 how much in the sense 7.5 into 10 to the power of minus 3. Concentration of H plus X. Concentration of H2PO4 minus is X. Concentration of H3PO4 is 0.1 minus X. Okay. Now let us simplify this in order to get this X value. While simplifying, don't neglect this X. Go for quadratic expression and simplify. Okay, so we are simplifying this expression by quadratic method, quadratic equation. This X we are not neglecting. Okay, so we have simplified this. We are getting X. X is equal to concentration of H plus, we can say. Similarly, we can say concentration of H2PO4 minus, we can say, that is equal to 0.024 molar. 0.024 molar. Okay, here we have not neglected X. 0.1 minus X we have taken as it is because equilibrium constant is 10 power minus 3. Okay, sir, we got X. Then we will calculate H3PO4. H3PO4 concentration is equal to 0.1 minus X. Now we will substitute X value, will substitute 0.024 will substitute. We are getting concentration of H3PO4. So concentration of H3PO4 here we are getting how much in the sense 0.076 molar. 0.076 molar we are getting. So we got H3PO4 concentration we got. Then we will calculate remaining species concentration. Remaining species in the sense this H2PO4 minus you take, this H2PO4 minus, it can act as a acid. This H2PO4 minus can act as an acid. H2PO4 minus. Therefore, we will go for H2PO4 minus acting as an acid. That equation we will take. Now, how to say H2PO4 minus can act as an acid? Because experimental evidence says that this H3PO4 is a tribasic acid. H3PO4 is a tribasic acid. Therefore, H2PO4 minus can donate H plus. That step we will see now. Now, H2PO4 minus H2PO4 minus H2PO4 minus is donating H plus and becoming HPO4 2 minus. HPO4 2 minus. Now H2PO4 minus concentration is how much? In the previous page we have seen H2PO4 minus concentration. How much means 0.024 molar and H plus also 0.024 molar. So H2PO4 minus is 0.024 molar. H plus in the previous equation we got 0.024 molar. This much H plus we got from H3PO4. Okay, sir. Here H2PO4 minus dissociating Y molar. How much remaining means 0.024 minus Y molar remaining. H plus produced Y molar. Therefore, H plus how much present now means 0.024 plus Y molar present. HPO4 2 minus produced Y molar. Now we will go for equilibrium constant, that is Ka2. For this Ka2 we have to say. Where we have to say Ka2 means this acid part is univalent, conjugate is bivalent. Like this should be there. Then only Ka2. Okay, sir. So right side thing we will write in the numerator, that is H plus into HPO4 2 minus. In the denominator we will write H2PO4 minus. H2PO4 minus we have written in the denominator. Now we will take Ka2, we will take Ka2 is how much in the sense here Ka2 is given, that is 6.2 into 10 power minus 8 is given, that we will take. So Ka2 is 6.2 into 10 to the power of minus 8, that we have written. Now we have to substitute H, these values we have to substitute. Now equilibrium constant is 10 power minus 8. Equilibrium constant 10 power minus 8 means equilibrium lies almost left. Therefore, we can neglect y. So it is nearly equal to 0.024. Here also we are neglecting y. Therefore, it is nearly equal to 0.024. Why we have neglected y now? Because equilibrium constant is 10 power minus 8. Very less. In the previous case, we did not neglect x because equilibrium constant is 10 power minus 3. So that we have not neglected. So now we will substitute H plus concentration is 0.024 molar. We will substitute HPO4 2 minus is Y we have written. and H2PO4 minus we will substitute 0.024. So we are getting y is equal to concentration of HPO4 2 minus, that is how much in the sense 6.2 into 10 to the power of minus 8 molar. This is a very less concentration. We can say this is a insignificant concentration. Insignificant concentration. They have asked us to calculate significant concentrations, but it is insignificant. Then this HPO4 2 minus can act as an acid by donating H plus. So HPO4 2 minus is donating H plus now. It is donating H plus and becoming what in the sense PO4 3 minus. Now HPO4 2 minus, how much initial means this is the initial value of HPO4 2 minus, that we can write 6.2 into 10 to the power of minus 8 molar. H plus we got so far in the previous equation is 0.024 molar. 0.024 molar of H plus we got till in the previous equation. Okay, now it is dissociating Z molar. Therefore, how much remaining means 6.2 into 10 to the power of minus 8 minus Z, we can say. H plus produced Z. Okay, so H plus how much present means 0.024 molar plus Z is present. 0.024 molar plus Z. That much H plus is present, plus Z molar is present. PO4 3 minus is produced, Z molar is present. Now we will go for Ka3. Ka3 is equal to Ka3 in the sense acid is bivalent, its conjugate is trivalent. Now Ka3 we have taken, right side we will write in the numerator, that is H plus into PO4 3 minus phosphate by the HPO4 2 minus we will write in the denominator. HPO4 2 minus we have written in the denominator. Now we will take Ka3 value. Ka3 value is given here, that is Ka3 is how much in the sense 3.6 into 10 power minus 13. This Ka3 is how much in the sense 3.6 into 10 power minus 13. That value will substitute. So 3.6 into 10 to the power of minus 13 we have substituted. H plus concentration we have to substitute. This Z we will neglect, then we will write it is as 0.024 molar. We will take, why we are neglecting Z in the sense this um, and this Ka3 is 10 power minus 13. Therefore, so H plus concentration will substitute 0.024. Then phosphate concentration we have to find it. Then HPO4 2 minus we will substitute here. In the HPO4 2 minus also we will neglect Z. Therefore, we will take 6.2 into 10 power minus 8 as it is. We will take, so we will substitute 6.2 into 10 power minus 8 we will substitute. We are simplifying. We are getting phosphate concentration. Phosphate concentration, how much we are getting means 9.3 into 10 to the power of minus 19. 10 power minus 19 molar we are getting. 10 power minus 19 molar in the sense it is a insignificant concentration. It is not significant. So insignificant concentration we are getting in this one. So in this sum, what are the concentrations we are getting in the sense one is H plus concentration, that is significant. Then H2PO4 minus concentration, significant. Then H3PO4 concentration at equilibrium, that is significant. Next we are getting a HPO4 2 minus concentration, that is insignificant. Then we are getting phosphate, that is insignificant. Okay, these are the concentrations we got. Next we will go for next sum. Here in this sum, what they're asking, you see that calculate pH of calculate pH they're asking for which one in the sense 10 power minus 3 molar H2SO4. Okay, so we have to find pH for 10 power minus 3 molar H2SO4 we have to find. Sorry, now we will take H2SO4. This H2SO4 concentration will take how much in the sense 10 to the power of minus 3 molar will take. This H2SO4 dissociating, this H2SO4 dissociating to give what in the sense H plus ions. Now what is this is a dibasic acid. It can give 2 H plus ions. Sulfuric acid can give 2 H plus ions. Dibasic acid it is. So we have to take whether Ka1 stage we have take or Ka2 stage we have take, they have not mentioned. So that we will consider complete ionization, and also sulfuric acid is a strong acid. Therefore, we can consider complete ionization we are considering. So 2 times H plus and SO4 2 minus we will take. Now sulfuric acid on complete ionization gives sulfate 10 power minus 3 molar. H plus is 2 into 10 power minus 3 molar. Okay, because sulfuric acid, one sulfuric acid gives 2 times H plus. Now we will take pH formula. pH is equal to minus log of H plus, minus log of H plus. Let us substitute H plus concentration. H plus is how much in the sense 2 into 10 to the power of minus 3. Now we will simplify this one. This we can write it as a minus log of 10 power minus 3 minus log of 2 we can write. Let us substitute the log value. This 3 minus 3 comes before, therefore plus 3. Log 10 is 1. Log 2 is 0.3010. Now we will subtract this one. We will get pH 2.698. Okay, we got pH of the solution. We got set. Next, next will 2.699. Sorry. Next sum we will take. In this one, next one is what in the sense 10 power minus 8 normal HCl. Now we will take 10 power minus 8 normal HCl. We will take concentration of HCl given is 10 to the power of minus 8 normal, which is equal to concentration of H plus we can say. Okay, concentration of HCl is equal to concentration of H plus because it is strong acid, undergoes complete ionization. Now we will take pH formula. pH is equal to minus log of H plus. H plus is 10 power minus 8 that we have substituted. We are simplifying. Minus 8 bring before, minus into minus 8 log 10. Log 10 is 1. Therefore we are getting how much in the sense pH is 8. Sir, pH is 8. We have got here pH is 8 in the sense whether this HCl solution is what? HCl solution is acid. HCl solution is acid in the sense pH is less than 7. Why pH is less than 7? Because they have not mentioned any temperature. They have not mentioned any temperature in the sense we have to consider 25 degrees Celsius only we have to consider. If temperature is mentioned, we can take what is the temperature mentioned that we can take. They have not mentioned the temperature, so temperature is 25 degrees Celsius. 25 degrees Celsius means pH is equal to 7 for neutral. pH is less than 7 for acid. Now, here this HCl in the sense, no doubt it is acid only. How do we say it is acid in the sense here solvent is not mentioned. Solvent is not mentioned in the sense solvent we have to take water. Therefore, it is aqueous solution of HCl. Aqueous solution of HCl certainly will act as acid, in that there is no doubt. So it is acid. Acid in the sense pH should be less than 7. But we are getting pH is greater than 7 we are getting. pH we are getting 8. That means we have committed some mistake. That's why we got pH is 8 we have got. So what is the mistake we have done? That we will see. Now we will take this aqueous solution of HCl we will take. This aqueous solution of HCl we are taking. In this aqueous solution of HCl, which species and all will be there, we'll see. This one is HCl dissociating to give H plus ions and Cl minus ions. This is one possibility is there. Another one, what is a possibility means in the aqueous solution in the sense water will be there. This water is dissociating to give H plus ions and OH minus ions. This equilibrium also there in the aqueous solution of HCl. In the aqueous solution of HCl, what is the equilibrium is there? Water is in equilibrium with H plus and OH minus ions. You take any aqueous solution. Aqueous solution in the sense certainly this equilibrium will be there. Water is in equilibrium with H plus and OH minus will be there. This equilibrium will be present if the solution is aqueous. Okay, sir. So we are considering this equilibrium also. Now here in this case, this H plus, HCl is giving H plus. HCl is giving how much H plus? 10 power minus 8 normal. Sorry. So 10 power minus 8 normal HCl giving H plus. So this water also dissociating. Water dissociating to give how much OH minus? Water dissociating to give how much OH minus? This we have discussed in a ionic product of water. In ionic product of water, what we have done in the sense we have taken pure water. In the pure water, Kw is equal to 10 power minus 14. Concentration of H plus equal to concentration of OH minus, that is equal to 10 power minus 7 we have seen. So concentration of OH minus is 10 power minus 7 molar. The H plus also 10 power minus 7 molar. And this HCl is giving 10 power minus 8 molar. Okay. But now in this solution, in this aqueous solution of HCl, now what are the equilibrium possible in the sense this equilibrium is possible. Shall we say concentration of OH minus in this solution concentration of OH minus is 10 power minus 7 molar, can we say? Then concentration of H plus shall we say 10 power minus 8 plus 10 power minus 7. This 10 power minus 8 in the sense HCl is contributing. 10 power minus 7 in the sense water is contributing. Like this shall we take? Because Kw is equal to ionic product is equal to 10 to the power of minus 14. That is equal to concentration of H plus into concentration of OH minus. Can we take like this? At 25 degrees Celsius in the sense Kw is 10 power minus 14. Whatever the solution, whether it is acid solution, basic solution, base solution, or salt solution, or pure water, anything you take Kw equal to 10 power minus 14 at 25 degrees Celsius, in that there is no doubt. So now can we take a concentration of OH minus is 10 power minus 7 molar or not in this aqueous solution of HCl? In the aqueous solution of HCl, shall we take concentration of OH minus 10 power minus 7? Whether it is correct or wrong, we will check it now. Now first we will take what in the sense pure water we will take. First we will take pure water. In the pure water, what is the equilibrium is there? First we will see. Water is in equilibrium with H plus and OH minus. Now concentration of H plus how much means 10 power minus 7 molar. Concentration of OH minus also 10 power minus 7 molar. KW is called a ionic product of water. It is equilibrium constant, that is equal to H plus concentration into OH minus concentration. H plus we substitute OH minus substitute, you are getting Kw, that is 10 power minus 14. Okay. Now let us add what in the sense, let us pass HCl gas into this. HCl gas into this pure water, let us pass. This pure water, let us consider 1 liter. We are passing HCl gas such that concentration of HCl, we are bringing how much in the sense 10 power minus 8 normal. For HCl, we can say normality, we can say even molarity word also we can use for HCl. HCl is a monobasic acid. N factor is 1. So normality is equal to molarity for HCl. Okay. Sorry, concentration of HCl we got. HCl is undergoing dissociation, isn't it? HCl is undergoing dissociation to give what in the sense H plus ions and Cl minus ions. How much H plus ions it will give? 10 power minus 8 normal it will give. Now we will write this equation, we will write this water gives H plus and OH minus will give. Okay, here we have written OH minus is 10 power minus 7, that we will write. Here we have written H plus is 10 power minus 7, that we will write. Then HCl is giving H plus 10 power minus 8, that 10 power minus 8 we will write. Okay, now you see that you are adding, you are passing HCl gas into this one. You are passing HCl gas into this one in the sense HCl is giving H plus to this. HCl is giving common ion to this equilibrium. HCl is giving H plus concentration. Therefore, this H plus concentration is getting raised. H plus concentration is getting raised in the sense this equilibrium will be disturbed. Equilibrium is disturbed in the sense backward is favoring. Therefore, backward is favoring means OH minus is disappearing X amount. H plus is a disappearing X amount will take. Therefore, how much OH minus present means 10 power minus X, 10 power minus 7 minus X is present. How much H plus present in the sense 10 power minus 8 plus 10 power minus 7 minus X is present. Like this we will take. Okay. Water is produced, corresponding amount of water is produced. Okay. Because common ion effect is there. Now we can let us say that system is attained new equilibrium. System is attained a new equilibrium, we have said. Is this point okay? So we got so and so. Here, what is the point in the sense? In the pure water, concentration of OH minus is how much in the sense? 10 power minus 7 molar. Concentration of H plus how much in the sense? 10 power minus 7 molar at 25 degrees Celsius. Kw is equal to 10 power minus 14. Okay. Now, we are passing HCl gas. This HCl gas is dissolving in water. Therefore, it is giving H plus ion. So that concentration of this H plus increases. Concentration of this H plus increases in the sense equilibrium is disturbed. Equilibrium is disturbed in the sense backward is favoring. Okay. Therefore, after some time, system will attain new equilibrium. System is attaining new equilibrium. In new equilibrium, concentration of OH minus is 10 power minus 7 minus X. Concentration of OH minus is 10 power minus 7 minus X. Concentration of H plus is this much. Okay, have we got idea? Sir. Next step we will see. Next step is in the for this new equilibrium constant is called Kw. that is equal to concentration of H plus into concentration of OH minus. Equilibrium constant Kw at 25 degrees Celsius is constant value, that is 10 power minus 14. If temperature is constant, Kw also constant. Ionic product of water depends on temperature only. So temperature, if we keep constant, ionic product of water remains constant. So Kw for pure water 10 power minus 14. Kw for acidic solution 10 power minus 14. Kw for basic solution 10 power minus 14. Kw for salt solution 10 power minus 14. Okay, whatever the solution you want to take it. Aqueous solution means Kw is 10 power minus 14 provided temperature is 25 degrees Celsius. If you change the temperature, Kw will change. If you do not change the temperature, Kw does not change. Okay, so now H plus value I will substitute. H plus is how much in the sense 10 power minus 8 plus OH minus concentration. It is H plus value. Then I will write OH minus concentration. I will write. Okay, so because you see OH minus is 10 power minus 7 minus x, then OH minus is 10 power minus 7 minus x. Therefore, I have written in the place of 10 power minus 7 minus x, I have written OH minus. Okay, sir. So 10 power minus 14 equal to 10 power minus 8 plus OH minus concentration into OH minus concentration we have written. Now let us simplify this quadratic expression. Let us simplify. We have to simplify this one by quadratic expression. We will get what in the sense concentration of OH minus, we will get it. So we are getting concentration of OH minus in this one. Okay, so concentration of OH minus is how much in the sense concentration of OH minus we are getting, that is equal to 9.51 into 10 to the power of minus 8 molar we are getting. So we got concentration of OH minus. Okay, then we will go for concentration of H plus. In order to find the pH, concentration of H plus is equal to 10 power minus 8 plus concentration of OH minus. Therefore, now we will substitute OH minus concentration 9.51 into 10 to the power of minus 8 molar we have substituted. Therefore, we are getting how much in the sense 10.51 into 10 to the power of minus 8 molar we got. Now we will take pH, we will go for pH. That pH formula we will take, pH is equal to what in the sense minus log of this H plus. This H plus value will substitute. Therefore, pH is equal to what we can get means minus log of 10 to the power of minus 8 minus log of 10 power 0.1 we are getting. So minus 8 we will take front, therefore it becomes plus 8 log 10 is 1 minus log 10.51 is 1.022. We are simplifying, we are getting how much in the sense 6.978. Now see the pH. pH of solution is less than 7. Okay, pH of this HCl solution is less than 7 we got, because HCl solution is acid, therefore only pH we are getting less than 7. Okay, now we will see in this case. So in order to calculate pH of this solution, in order to calculate pH of this solution, we have taken what in the sense now this here 10 power minus 8 normal HCl solution. To calculate pH of this solution, we are considering this equilibrium we are considering. Okay, this equilibrium we are considering. But to calculate pH of this solution, to calculate pH of this solution, we are not considering this equilibrium. Why? To calculate pH of this solution, to calculate pH of this solution, we are not considering this equilibrium. Why? Because concentration of acid is higher than concentration of H plus contributed by water. Okay, so concentration of acid is higher than concentration of H plus contributed by water. So that concentration of H plus contributed by water is negligible when compared to concentration of H plus provided by acid. Have we got idea? Sir. Next, we will go for and third one 10 power 2m HCl. 10 power 2m HCl. For that, how to find pH, that we will see. So now we are going for 10 power 2m HCl. For that, we have to find pH. Okay. Now 10 power 2m HCl. For this, concentration of HCl is 10 power 2m means concentration of H plus is equal to 10 to the power of 2m. Okay, concentration of H plus we know, therefore we are going for pH. pH is equal to minus log of active mass of H plus. Okay, this is the formula for pH. pH is equal to minus log of active mass of H plus. This active mass of H plus, active mass of H plus is equal to activity coefficient of H plus into concentration of H plus. Okay, this bracket is square bracket indicates molarity of H plus or normality of H plus. So active mass of H plus is equal to activity coefficient into H plus concentration. For very dilute solution, activity coefficient is equal to 1. For very dilute solution, activity coefficient is 1. Now given is a 10 power 2 molar. This is not very dilute solution. Very dilute solution in the sense 10 power minus 1, 10 power minus 2, 10 power minus 3, 10 power minus 4, like this we have to take. Okay, so 1 molar, 2 molar, 3 molar, 10 molar, 10 power 3 molar, like this and all very dilute solution not. So the given solution is not very dilute solution. Okay, if the concentration is given 1 molar or greater than 1 molar means don't consider that is as very dilute solution. Therefore given solution is not very dilute solution. Therefore activity coefficient is not equal to 1. So activity coefficient is not given in the sum. Therefore we cannot find pH for this sum. Okay, we cannot find pH for this sum. Okay, so if the H plus concentration is given in terms of 10 power minus 1, 10 power minus, that means less than 1. If the concentration of H plus is given less than 1, then only we can calculate pH using this formula. Otherwise we want activity coefficient. So for this sum we cannot find a pH we cannot find. Okay, this here logarithm and all values will be given in the sum. Logarithmic values and all given in the brackets in the exam. Okay, next sum we will take. Calculate pH for a 0.01 normal calcium hydroxide. Okay, so now calcium hydroxide will take. Calcium hydroxide, it is dissociating to give what in the sense calcium ions and hydroxide ions. Hydroxide ions it is giving. Okay, now calcium hydroxide dissociating to how much extent is not mentioned, so we will consider complete dissociation. We will consider, therefore how much calcium ion is produced in the sense 0.01 normal. 0.01 normal we can say, 0.01 normal we are saying, 0.01 normal. Hydroxide how much produced means 0.01 normal only we have to say. Don't multiply this by 2. Don't multiply this by 2 because it is normality given. Normality is given in the sense, don't consider that here 2 times is there, therefore we have to multiply this by 2. We should not consider. Why? Normality is given means why we should not multiply by 2. That means now how I am reading this equation, you see, 1 gram equivalent of calcium hydroxide gives 1 gram equivalent of calcium ions and 1 gram equivalent of hydroxide. I will read this equation in another form. See, this dissociation. 1 mole of calcium hydroxide on dissociation gives 1 mole of calcium ions and 2 moles of hydroxide ions. Okay. In terms of moles time, balanced equation, as per balanced equation, we have to follow. Next step. In another form, I will read this equation. This 1 molecule of calcium hydroxide on dissociation gives 1 calcium ion and 2 hydroxide ions. Okay. Now I will read in terms of equivalence. I will read this one in terms of equivalency. 1 equivalent of calcium hydroxide gives 1 equivalent of calcium ions and 1 equivalent of hydroxide ion we have to say, not 2 equivalents. 1 equivalent of hydroxide only we have to say. Okay, balanced equation we should not consider. 1 equivalent, suppose X equivalents of calcium hydroxide on dissociation gives X equivalents of calcium ions and X equivalents of hydroxide ions. Why? Like this. That means you see, now suppose we are taking equivalent mass of calcium hydroxide. Equivalent mass of calcium hydroxide, how we have to find it, do you know? Equivalent mass of calcium ion plus equivalent mass of hydroxide ion. Like this only we have to add. equivalent mass of calcium hydroxide is equal to equivalent mass of calcium ion plus equivalent mass of hydroxide ion. Like this we have to say. Equivalent mass means one equivalent. How we are saying 1 mole, 2 moles, 3 moles like this. Like that, equivalent mass means one equivalent of calcium hydroxide. One equivalent. For molarity, we are saying number of moles. For normality, we have to say number of equivalents we have to say. So calcium hydroxide one equivalent mass means that is equal to equivalent mass of calcium ion means that is one equivalent of calcium ion. One equivalent of calcium ion plus equivalent mass of hydroxide means one equivalent of hydroxide. So one equivalent of calcium hydroxide is equal to one equivalent of calcium ion plus one equivalent of hydroxide. Like that only we have to say. That's why the word given equivalent. So don't see as per balanced stoichiometric coefficients. Okay, so we have said one equivalent of calcium hydroxide equal to like this. Suppose in terms of molecular mass means how do we say? That also we'll see. Molar mass, molecular mass we'll say as molar mass. Molar mass of calcium hydroxide we can say equal to ionic mass of calcium ion because calcium is ion plus 2 into ionic mass of hydroxide ion. Ionic mass of hydroxide means oxygen is 16, hydrogen is 1, 17 ionic mass. So molar mass of calcium hydroxide means how we are calculating, see, ionic mass of calcium ion plus 2 into ionic mass of hydroxide. Hydroxide 2 times you have to take. Molar mass means. Because how to read one mole of calcium hydroxide contains 1 mole of calcium ions and 2 moles of hydroxide ions. But it is, you know, that this one you know. But regarding equivalence in the sense, understand that one equivalent of calcium hydroxide contains one equivalent of calcium ion and one equivalent of hydroxide. Don't say two equivalents of hydroxide. Okay, therefore this calcium hydroxide concentration is 0.01 normal. It is undergoing complete dissociation we are taking because dissociation constant is not given, so that we are taking like this. One this calcium hydroxide completely dissociating means it is giving 0.01 normal calcium and 0.01 normal hydroxide. Okay, so now we will find a pH. For this one we will find now pH is equal to what we can say means minus log of H plus we can say. So now we want H plus concentration. We know OH minus concentration. Therefore, you take Kw is equal to concentration of H plus into OH minus. So substitute Kw. Kw is 10 power minus 14 equal to H plus concentration we want. OH minus concentration is how much means 10 power minus 2. So simplify, you are getting concentration of H plus that is equal to how much means 10 power minus 12. Substitute in this formula, pH formula, we are getting pH is equal to how much means 12 we are getting. Okay, so pH is equal to 12 we got. Next sum we have to do what in the sense 10 power minus 8 molar sodium hydroxide we have to find. 10 power minus 8 molar sodium hydroxide. How to find pH for this, that we will see. Okay, so we have taken a sodium hydroxide. Sodium hydroxide concentration is equal to 10 to the power of minus 8 molar. For sodium hydroxide, normality is equal to molarity because it is a monoacidic base. It can give one OH minus only. Therefore, monoacidic base. So we can say normality equal to molarity. This is equal to concentration of hydroxide. Okay. So concentration of hydroxide we got. Let us find a Kw is equal to